Yeah. Yeah. Yeah, good evening all. So myself, I'm Vijay. I hold 16 plus years of experience, which includes 8 plus years of experience in big data, Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether my screen is visible or not? Right.
Yes, sir. Everything is okay.
Fine.
Yeah,
Thank you.
yeah, sir.
Fine. So as part of today's demo, just I'm going to cover the following part. Like that. What is big data? Why Hadoop again? Drawbacks, databases, Hadoop advantages, Hadoop ecosystem components, and Hadoop job market. So what is the big data? What is big data? So the name itself saying like huge volumes of data. Big data, nothing but like huge volumes of data, right? Now, how the data is getting stored? Currently, how the data is getting stored? Like KBs of data, so MBs of data, GBs, gigabytes, terabytes, petabytes, exabytes, zettabytes, etabytes, ottabytes, so on, right? Yes. So, sorry, it's GBs of data. Okay. So you should have seen like KBs of data, MBs of data, or even GBs of data. Should have seen TBs of data. Do you think like petabytes or exabytes of data is it getting generated in the current real world? Examples of petabytes or exabytes of data generation if it is getting generated, right? So 1 petabyte equal to 1024 TBs, right? 1 petabyte, 1 PB, if I can say 1024 TBs, right? Okay. Examples of petabytes of data generation, nothing but like if you take the example of any banking sector, like if you take the example of any bank like SBI or HDFC, right? If you take bank like SBI or HDFC, within a city you see hundreds of branches for that bank. Within the state you see thousands of branches for that particular bank. Within the entire country, lakhs of branches for that particular bank. So within that each branch again like millions of customers, right? Each customer making multiple transactions per hour, per day, per month, per week, right? Per year. Each and every transaction need to be stored, right? So huge data is getting generated, right? Forget about this banking sector. You are aware about social media like Facebook, right? Facebook, right? What is the data generated by Facebook in a minute? Facebook has got millions and trillions of users throughout the world, not only within the country. It has got millions and trillions of users throughout the world. How many posts and videos are getting circulated in a minute? What is the data generation of Facebook in a minute? It's not like GBs or TBs, right? Huge data is getting generated, right? Okay, each and every post and video need to be stored. Not only like Facebook, we have got many other applications, right, which is going to generate huge data currently. If I talk about only 1 minute, if I talk about 1 minute transaction, right? Huge data is getting generated. Fine. 1 minute. If I talk about 1 minute, in a minute, how many FB posts, how many Facebook posts, right? Yes. How many like Twitter tweets? Talk like in a minute, how many like Google queries? What is the data generated by Google in a minute, right? Everyone creating your own videos and uploading in the YouTube, right? YouTube videos upload, right? In YouTube videos upload, what should be the storage capacity of it? Or email or Gmail messages, right? Or email or Gmail messages, millions and trillions of users, right? What should be the storage capacity for this? Just now I was talking about bank transactions, lakhs of branches, each branch like millions of customers, like bank transactions. Or if we talk about like telecom transactions, or if we talk about e-commerce sites, e-commerce websites like Flipkart or Amazon, right? So everywhere, if you see currently huge data generation, you are able to see in Facebook, Twitter, Google, like in telecom transactions, YouTube, huge data generations. For storing this huge data, for data storage, currently we have got some databases. We have got some databases like Oracle, MySQL, SQL Server, DB2. These databases are used for day-to-day operations. They are used for OLTP, online transactional processing. They can handle data up to some extent, right? Databases like Oracle, MySQL, SQL Server, DB2. We have got some specialized databases. Like Teradata, Netija, Vertica. Okay, these databases, right? They are used for OLAP, online analytical processing, or data warehouse for DWH, right? They are used for data warehouse purposes, right? OLAP. Okay, either these databases are specialized databases, they can handle data up to some extent, but beyond that, they cannot handle the data, right? So as a solution for this huge data storage and huge data processing, right? As a solution to this, we have got a framework called Hadoop for storage of huge data and processing that huge data in quick time. Later I'll come back to this Hadoop, but before that, let me show you like the data generation, right? If you see how the data getting generated. 1 second. If you talk, this is the data, right? If this is the data which got generated from the last 50 years, assume this is the data. If you talk like from 1970 to like 2022, right? Okay, if you see 1970 to like 2012, if you see like if 25% of the data got generated between these 40 years, right? But if you compare the last 10 years, if you see the last 10 years, 70% of the data, whatever we see, got generated from the last 10 years itself, right? Previous 40 years, only 25% of the data. But last 10 years, 75% of the data has got generated, right? The reasons for huge data generations, especially from the last 10 years, because of usage of technology, usage of smartphones, usage of internet, right? So previously, if you talk about in 1990s or 1980s, right, there was no smartphones, internet usage was less. So now you can see like huge data generations, especially from the last 10 years, right? What are the main sources? What are the main? So if you talk about 1990s or 19 like early 2000s, right? For example, you are aware about the how we are going to carry the data, right? Floppy disk. We got floppy disks of size 1.44 MB. Later you got like compact disks of 700 MB, right? In MBs. Later you got DVDs in GBs, next to USBs. Like so, as data is increasing, your storage capacity is also increasing, right? But now, if we talk about GBs or TBs currently, if you see that in the earlier stages of mobile phones, that internal storage of 256 MB was high storage, but now even like 256 GB, right? It's a very small storage now. So as data is increasing, the storage systems also need to be increased, right? 75% of the data. Okay, what are the main sources from where this data is getting generated, right? What are the main sources? Mainly like we have got three sources of data, right? From where this data is getting generated. What are the main sources? Mainly like three sources, like social data, I can say, machine data, and a transactional data. Social data, machine data, and transactional data. Social data, the data which got generated from social websites like Twitter, Facebook, all this, like we call such data as social data. Machine data, the data which got generated from by reading or scanning the barcode scanners, RFID chips, such kind of data we call it as machine data. Transactional data from day-to-day operations like bank transactions, telecom transactions, right? So these are the mainly three sources from where the data getting generated, right? Social data, machine data, and transactional data. And this data is going to occupy like three types or three formats, right? Three types of data. Structured data, semi-structured data, and unstructured data, right? Structured data, semi-structured, and unstructured data. Structured data, data which is organized in the form of rows and columns in a structured format, like Excel sheets, database tables, right? DB tables. And semi-structured data, which is not fully structured, which is not fully unstructured, right? Like JSON files, XML files, all this comes as semi-structured, right? Unstructured, which is like chart messages, articles, images.
Hello, sir.
Yes.
Sir, can you actually? I am right now in my office, so can you please discuss the syllabus of this course?
Yeah. Yes. Fine. Okay, I'll come back to it. Okay, fine. So what are the things I'm going to cover as part of this, both like Hadoop and Spark? 1 second, I'll come back to this. So both Hadoop and Spark components I'm going to discuss, right? Okay, Hadoop. Hadoop and Spark with SCALA, right? Spark with SCALA implementation. So introduction to this Hadoop HDFS components, file system, Hadoop distributed file system, MapReduce, Scoop, SQL plus Hadoop, right? Yarn, yet another resource negotiator, right? Everything in brief, right? Pig, Apache Pig, Hive, lot of discussion will be there on Hive, right? So the components which are mostly used, right? Like Hive, Scoop, these things I'll be mostly discussing with multiple working examples, right? So like different types of tables, loading data from locals to HTML, working with XML data, JSON data, working with URL logs and weblog data, unions, filters like UDF, UDAF, UDTFs, and partition table, non-partition table, bucketing, indexing, right? In the Hive multi-column partitioning, dynamic partitioning, performance tuning mechanism in Hive, bucketing, indexing, right? And NoSQL database like HBase. We are going to be discussing one NoSQL database like HBase. Coming to the Spark side, right? Spark programming. Before I discuss Spark, SCALA programming. SCALA totally in brief. SCALA control statements, SCALA collections, SCALA transformations, SCALA functions, and Spark core programming, Spark comparison with other technologies, and RTD, resilient distributed data sets, and persistence options in Spark, Spark core computing, the fault tolerance mechanism, different ways of creations, Spark data objects, increasing the number of partitions, aggregations over the structured data, groupings and aggregations, and various built-in transformations and built-in actions, right? One by one transformations and actions in brief, right? And Spark SQL component, right? We're making the data structured, working with case classes, extracting these case classes, data frame API, data sets, and Spark and Hive integration, Spark and MySQL, and working with CSV, JSON data, and the deployment modes in local and cluster and Spark applications, Spark job submission, submitting Spark job, like using Eclipse ID, using IntelliJ ID, using build tools like Maven build tool, SBT build tool, and Spark and Cassandra, right? And apart from this, I'll be giving knowledge on streaming data and technologies like Flume Kafka, and also like Spark streaming, also micro batching, DS streams, right? So these things I'm going to cover, right? It's both Hadoop and Spark combined. Fine. So
Spark is PySpark, right?
pardon?
Spark and PySpark is same.
Yeah. See, 1 second. Spark is a execution model. Spark can be implemented using the SCALA language. Spark can be implemented using Python. Spark can be implemented using Java or R language. But Spark, native language of Spark is SCALA, mostly used Python. These two are mostly used, right? Spark with SCALA language implementation, Spark with Python language implementation, right? So Spark with Python language is generally say like PySpark, right? And Spark with SCALA here it is. And there is a weekend batch, right? There is a weekend batch on PySpark going to start from this weekend only. If you want to get updated with PySpark, there is a weekend batch going to start from in Saturday 5:30 p.m. and Sunday, right? Saturday and Sunday at 5:30 p.m. in the evening IST timing. But in this course we'll be having discuss on Hadoop and Spark with SCALA, right? SCALA language. Fine.
Sir, what are the prerequisites of this course, sir?
Okay. So I just as they asked syllabus, right? Just I was showing you the syllabus, right? Just let me discuss, right? What are the things I need to discuss at the end of that session? I'll be giving time for your general queries. Okay, I'll come back to your queries, right? At the last.
Sir, one more thing I was
Yes.
asking. So like PySpark, we have to study, right? Because it is mandatory when coming to data engineer, Hadoop side, right?
Yes.
Okay, but it is on weekend batch only. You are not going to cover, right?
So here in this Hadoop and Spark with SCALA, right? Spark by default built by using SCALA language. It's a native language of Spark. And if you want to update with the Spark with the Python language like PySpark also, it's a weekend batch available.
Okay. So here is Spark with SCALA, and if a Spark with Python, that is called the PySpark. For that we can batch, right?
Yes, we can.
We can't use Python here, PySpark. Like
here it is only SCALA. Here only SCALA. If any people, if you want to prefer, you can go for PySpark batch in that weekend session. Like only like Saturday, Sunday, 2.5 hours.
Okay. So SCALA is
there any,
same as Python.
is there any
SCALA?
prerequisite, sir, to attend PySpark?
PySpark, everything will be dealing clearly, right? Everything from the scratch, everything. No, like you need to have the knowledge of Python. Basic knowledge of Python is required. Okay. Remaining everything I'll take care, right? Okay, fine.
So PySpark, we can batch you will take, sir. You are
Yeah, I'm taking.
okay, fine.
Okay, fine, that's fine. I'll come back to your queries right at the end of the session. So here, if you feel like huge data is increasing enormously, but we need to have proper storage and processing systems, right? So as the solution to all these storage and processing level issues, right? We have got a framework. We have got a framework called Hadoop, which is meant for both. It is going to perform two things like for storage and processing. For storage and processing, Hadoop is meant for both storing and processing the data, right? If we talk about any technology, right, it is either for storage or for processing. If you take any programming language like C or C++ or Java or this .NET, right, they are meant for processing. Or if you take any storage like databases like Oracle, MySQL or DB2, they are meant for storage. Means either they are meant for storage or either they're meant for processing. But Hadoop combines both, like it is meant for both storage and for processing. So you may get some queries, right? So when Hadoop is able to perform both storage and processing, what is the necessity of this current processing and storage technologies at this one? Where Hadoop is able to accommodate huge data, unlimited data, right? So what is the necessity of the current storage and processing? Yes. Do you think that these storage and processing technologies will go away from the market when Hadoop in the market? So Hadoop is meant for batch processing, huge data like millions and trillions of records, right? For a single transaction, right? For one transaction or two transactions, we won't go for Hadoop, right? So we go for this normal data, and Hadoop is not for OLTP, day-to-day operations, not for online transactional processing, batch processing, millions and trillions of records. Does Hadoop use any database for storing its data? Does Hadoop use any database for storing its data? No. We have got some drawbacks with the databases. Despite with the drawbacks, still Hadoop doesn't go with any database for storing its data. It goes with a special kind of file system. We call it as Hadoop distributed file system. And for processing, right, we go for execution models like MapReduce, Spark, right? For processing, now currently we are going with Spark. Previously, like MapReduce was mostly used. So Hadoop is meant providing two services like storage and processing. For storage, like HDFS file system, and for processing, MapReduce, that is Spark, right? Both combinedly, both can store and process the data, right? Okay, fine. Drawbacks with the databases. Why databases like Oracle cannot be used for storing Hadoop's data? Why databases like Hadoop can't be used for storing this Hadoop data, right? Yes. I'm sorry. Okay, drawback with databases. Drawback with databases, right? Yes. Limited storage. First is what? Limited storage, right? They cannot handle huge data or unlimited data, right? Limited storage capacity. Most of the databases, no parallel processing. In most of the databases, no parallel processing you are going to observe. Okay. If volume increases, speed decreasing, right? Volume increases, speed decreases, right? Yes. For example, if I take a query selected sum of amount, total amount from sales one. Select one more query like sum of total amount or sum of amount from sales two. One more query, select sum of amount, total amount, right, from sales three. Think that the first table has got 10 records, 100 records. Assume it has got some 100 records. This table two, sales two has got like 1 lakh records. The sales three has got 1 crore records, right? 1 crore records. So query to query, if you observe query to query, so total amount from sales one, total amount from sales two, total amount from sales three, right? Query to query, as the volume increasing, which query is going to execute faster among all these three? Total amount of 100 records or 1 lakh records or 1 crore records, which query is going to execute faster among these three? First query, right? Obviously the first query, right? Query to query, as data increasing, right, the volume decreases, the speed decreases, right? As volume increasing, speed decreasing, right? The first query executes faster as compared to the other two queries, right? Okay, next. Complexity increases. Complexity increases, right? Speed decreases, right? So volume increases, speed decreases, complexity increases, and the speed decreases. Right? Complexity means, for example, take the same query. Observe this. Select sum of amount from sales one, right? Same thing like the same query. This time average amount. Select average amount from sales one. Select standard deviation of amount, right? Standard deviation of amount, like standard deviation of amount from sales one, right? Observe this. Which query? See the sales one, sales one, sales one. Think that you have got some 1 crore records, right? Which query is going to execute faster among these three queries? Sum of amount, average amount, standard deviation of amount, right? Okay. Total amount from sales one or average amount from sales one, right? First query is going to execute faster because second query is the average amount is a two-step process, right? First sum to be calculated, next average to be calculated. Standard deviation of amount, lot of internal processing required as compared with the other two queries, right? So query to query, as the complexity increasing, speed decreasing, right? Yes. And mainly the main drawback of databases can handle only structured data. They can handle only the structured data. Databases can handle only the structured data. They cannot handle unstructured or semi-structured kind of data, right? They can handle only structured data. For example, if I want to take reviews for a particular movie, right? For example, answer this. Want to take reviews for a particular movie. Okay. For example, I got a table like this. User review. User review. User one, user two, user three. In this way, 100 users, right? 100 users. If the movie is good, saying it's one, movie is bad, saying zero, giving the feedback in the form of ones and zeros, right? Can you write an SQL query to count the number of zeros and ones here? Can you write an SQL query? It is in a structured format, rows and columns, 2 columns, right? 100 rows. Can you write an SQL query to count the number of zeros and ones? Select review wise, count I want, review wise, count star from reviews. From reviews, group by. Select review wise, count I want from reviews, group by review. So think that the output tab. Ones and zeros. 90 people saying the movie is good, 10 people saying the movie is bad, right? So we can write an SQL query for this kind of structured rows and column set, but group by review, right? Okay. But generally, the users won't give the feedback in the form of ones and zeros, right? They give in their own text format. First person saying movie is good. Second person saying that movie is not good. So they are giving the feedback in their own text format, right? For this, can you write an SQL query saying how many people saying it's good, how many saying it's not good? Can you write an SQL query to count the number of goods and not goods? No, right? So databases cannot handle this kind of data, right? You can handle only structured data. So these are the major drawbacks, right? Limited storage, no parallel processing, volume, complexity increasing, speed decreases. Databases can handle only structured data, right? Yes. So despite of these drawbacks, right? Hadoop doesn't use this databases for storing its data. Rather, it's going with a special kind of file system called Hadoop distributed file system. Just Hadoop advantages, right? Advantages of Hadoop. Hadoop advantages. So before I discuss this Hadoop advantages, to understand this, right, you need to understand something about this Hadoop basic architecture, right? Yes. So, and now I'll be just giving you overview about it, but later we discuss in brief, in depth about this architecture, right? Yes. Hadoop doesn't follow client server architecture. It follows like a master slave architecture, right? Master slave architecture. This is the master node. This is slave 1, slave 2, slave 3. N number of slaves. Okay. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. f1.txt. It's a txt file. Think that every system, the hard disk capacity, 1 TB, 1 TB, 1 TB. It's f1.txt is of 2 TB, right? Can it fit into any of these slaves? It cannot fit into any of these slaves, right? As they have got only 1 TB capacity. So in Hadoop, always the data to be divided into smaller parts. Each part is going to be stored across this months. Second one, third one. Data is going to be distributed. This 2 TB file data is going to be distributed, right? It's going to be divided into smaller parts. Each part is going to be stored across these multiple slaves and processed parallelly, right? Data is distributed only, then parallel processing can happen, right? Think that 1 lakh records in this, 1 lakh records in this, 1 lakh records in this, 1 lakh records. So all the slaves are going to process this 1 lakh records parallelly. So if data is increasing, your slaves are going to get increased. If your data increased, okay, data increased by 100 times, customer increased by 1,000 times. You cannot go with the same number of slaves, right? You are going to increase the slaves. Okay, horizontally unlimited scalability. You can keep on adding the slave machines. Data increasing, your slaves are going to get increased. Okay. What are now Hadoop advantages, right? Hadoop advantages. Unlimited data storage. Unlimited data storage. Unlimited data storage. Second, like that. Very high speed processing. Very high speed processing, right? And can handle all varieties of data, right? Can handle all the varieties of data. Can handle all the varieties of data. Open source, no licensing required. No. Mainly unlimited data storage. Unlimited data storage because of a feature, horizontally unlimited scalability. Horizontally unlimited. Horizontally unlimited number of slaves can be added. If you observe this diagram, right? If you're running a very small business with 10 slaves, tomorrow your slaves have increased, means your data is increased. The customers are increased. You cannot go with the same number of slaves, right? Yes. Data increasing, slaves are going to increase. Horizontally unlimited number of slaves.
I have a question, basically.
Yes.
When you say unlimited data storage, a lot of applications will be using the same storage, right? It's the central storage. And the company definitely has to pay for the storage, right? If you say when we are adding the slaves, it is cost. It's cost, right?
Yes. So okay, if you want to go for a huge storage, means depends upon your data volumes, right? For a cluster, we are going to create a cluster, right, with a number of nodes, depending
Okay.
upon the data volume, right? So how many node cluster? 40 node cluster, 100 node cluster, depends upon your data volumes. If you have got data increasing, your slaves need to, we say like commissioning and decommissioning, adding and removing slaves, right? For more number of slaves required. Slave machines, CPUs, right? So here master node and slave nodes, CPUs. This we call it as a cluster. So I'll be discussing about the Hadoop architecture, but so this we call it as a group of CPUs connected in a network. This is a master node. These are slave nodes. All these are CPUs connected in a network.
So this is one cluster and will have many number of clusters.
So so here your cluster depends upon your data volume. One master, multiple slaves, right? So your Hadoop file is divided into smaller parts and distributed across multiple slaves, stored across multiple slaves and processed parallelly. That is the two advantages what we see in Hadoop: distributed storage, parallel processing.
Okay.
Data is stored across multiple slaves, multiple systems, processed parallelly. your data is going to be stored across multiple systems and are processed parallelly, right? Fine.
One more question, sorry. So when you say the data is distributed across the slaves, so how is the data distributed? Like randomly, suppose this file has 100 records.
Yes,
So
yes.
it will be like evenly distributed among 4,
How
like 20,
exactly,
20, 20, 20.
how exactly the data storage is happening? Generally, we have got see, data is divided into fixed size blocks, fixed size chunks. We say them as blocks. We call them as a block. Default block size 128 MB. 128 MB blocks. 128, 128, 128 MB blocks.
Okay.
So each block will be of fixed size. So okay. So from Hadoop 2 version onwards, we got 128 MB as the fixed default block size. But if you want to configure, we can increase or decrease the block size.
Okay.
If you want, we can just configure by giving 200 MB as my default block size, or even I can use 100 or 50, depends upon our data. So I can by default, if you're not setting, if you're not configuring, it will be like 128 MB.
Okay.
Fixed size, right? It's divided into this.
Okay. So who will be doing this configuration, as a developer or someone from the admin team?
So I'll be discussing how exactly the data storage and data processing is going to happen, right, within this Hadoop. So everything they were taken care by developer only.
Okay.
Unlimited data storage, horizontally unlimited scale. This is the feature we got in Hadoop. Horizontally unlimited number of slaves we can keep on adding, right? Very high speed processing, because of parallel processing. No? Because of parallel processing. Okay. If you want to see that the Hadoop speed as compared, like there was a test conducted, Yahoo has conducted a test to check the speed of various databases, right? It has taken a table. Of size 100 TB, consisting of 1024 columns. The task sorting based on 16 columns. Sorting based on 16 columns. So the time taken by these various databases, right? Like Oracle, it has taken nearly 3.5 days to process it. MySQL, it has taken nearly 6 days to process this. Okay. Teradata, a specialized database used for data warehouse, it has just taken 4.5 hours, right? Teradata has just taken 4.5 hours. Netija, another specialized database used for data warehouse, but like it has just taken 3 hours, right? Finally, like Hadoop, Hadoop has just taken 3.4 minutes, right? For processing. 3.4 latest version of Hadoop has just taken 1.2 minutes, right? So this is what the speed of Hadoop as compared with that other, okay? Like 3.4 minutes or 1.2 minutes as compared with 3.5 days and 6 days. This is the speed of Hadoop, right? Very high speed because of this parallel processing. High speed processing. It is meant for both storing and processing, storing unlimited data, processing the data using quick time, processing the data in quick time because of this parallel processing. And it can handle all varieties of data, structured, unstructured, and semi-structured kind of data, right? Hadoop can handle all this, right? And it's open source, no licensing required. It's like kind of cost cutting. Fine. Observe. So Hadoop ecosystem components, right? So we have got some storage and processing components, right? Like we have got HDFS, Hadoop Distributed File System. We have got a file system called Hadoop Distributed File System. It is meant for storage. We doesn't use any databases. I said some of the drawbacks. I'm saying the drawbacks of databases as compared with Hadoop only, right? Like less storage, no parallel processing, as can handle only structured data, right? So HDFS is meant for storage, and we have got MapReduce. It is an execution model. It's meant for processing, but previously we used to use MapReduce a lot, but the usage of MapReduce has decreased a lot in these days. It is meant for processing components. So as part of this course, right, I'll be giving knowledge on this MapReduce with some examples, not that many examples, right, because it's not, Spark is mostly used. Spark is 100 times faster than MapReduce. Okay, Pig, Apache Pig, right? Apache Pig, the Apache Pig, the advantage of Pig. This is also a processing component. Pig is also a processing component. We use a language called Pig Latin language. It's a simple scripting language, Pig Latin, where complex tasks can be dealt with in a simpler way, right? Means like, for example, huge codings you can write in a simple, like a very less code, right? Very less code. Pig Latin language, any tasks, the scripting language, it's a data flow language. Next, Hive, Apache Hive, right? This is the component mostly used in our projects, right? Hive is a kind of data warehouse kind of environment within the Hadoop framework. We use a language called HQL, Hive Query Language, similar to SQL language, right? Hive Query Language. So here we are going to make the data structured and create tables, and we are going to query the data, okay? And we have got different types of tables here, like the partition, non-partition, external and internal, right? Scoop. SQL plus Hadoop, right? SQL plus Hadoop. The first two characters of this and last three characters of this. First two and last three. SQOOP. SQOOP. Scoop, right? Yes. For import and export operations, one of the data ingestion tool, right? For import and export operation. Importing data from databases to Hadoop and exporting data from Hadoop to databases, import and export operations, right? Yarn, yet another resource negotiator, right? So from Hadoop 2 onwards, we have got a lot of changes, architectural changes. We've got the drawbacks, the previous drawbacks, everything we have gone overcome in this from Hadoop 2 version onwards. And NoSQL database. NoSQL database. Hadoop can perform only batch processing. It cannot perform online processing. To perform online processing, we can integrate Hadoop with NoSQL, which can perform this online processing also, right? Like here you can see like schema-less behavior, NoSQL, not only SQL, right? Schema-less behavior. If you talk about this SQL, right? Schema compulsory, we need to define that column name, data type, everything. First record to last record, the same number of fields need to be maintained in data in SQL. But in NoSQL, my first record with 3 fields, second record with 5 fields, third record with 10 fields. Record to record, different number of fields can be maintained, right? Schema-less behavior we can see in NoSQL. Random access. In Hadoop, we see like sequential access, here like random access. Okay, as part of our course, like we are going to discuss like HBase. HBase is one of the NoSQL database, means especially for Hadoop, it works only for Hadoop environment. HBase is a NoSQL which works only for Hadoop environment, right? Not for other environment. But if we talk like we have what NoSQL databases like Cassandra, MongoDB, these are not only for Hadoop environment, that is for open application. We have got many NoSQL databases. Okay, graph store, columnar store, document store, graph store, right? Okay. Key value store. So we have got like HBase, Cassandra, MongoDB, React, Peanut, Neo4j, many NoSQL. Among this, Cassandra, MongoDB, HBase are the famous one. Okay. It's for Hadoop. Next, like some streaming data and technologies. I'll be giving knowledge on the streaming data and technologies. Okay. Like Flume Kafka. Mostly on Kafka, mostly used Flume Kafka for streaming data and technologies, for streaming data, for capturing live streaming data, right? So streaming data means the data which keeps on incrementing, the data which keeps on generating, right? Which keeps on incrementing. Such kind of data we call such kind of data. Okay, capturing by using this Flume Kafka. Okay. Okay. Apart from next, like coming to this Spark side, right? Okay, we have got some components like the Zookeeper, which controls and coordinates all the Hadoop components, right? Yes. Next, like coming to the Spark, right? Very high speed processing in memory computation. So in Spark, I'll be discussing first here. Programming goes in SCALA language, Spark core program. We have got many built-in transformations and we got built-in actions, right? How to make the data structured, schema RTDs, like that. And next is like Spark SQL. Spark SQL, right? We have got the concept of data frames and data sets here. And Spark streaming, micro batching, DS streams. Fine. This is what I'm going to discuss, right? Next. So nearly like that. Spark core, Spark SQL, Spark streaming. So nearly like 50 hours I'll be spending on this Spark, right? 45 to 50 hours. Okay. And nearly on 30 to 40 hours to Hadoop. So totally it comes like 80 to 90 hours. So it takes 2 months, right? 2.5 months we'll be discussing about these things, right? So 1.5 months I'll be taking on this Spark. Nearly 1 month I'll be discussing on Hadoop, right? The importantly I'll be discussing more concentration on Hive, Scoop, Yarn. Yes. No SQL databases, right? So if you've got any queries, you can just ask your queries. And tomorrow also you can attend the session same time using the same link to see more on this, right? I'll be just discussing why databases cannot be used as this, and storage point of view, how Hadoop has proven in the market, right? And how exactly the data storage and data processing is going to happen within this Hadoop. Okay, the other things, right? So because of this, I just give an example, right? The speed of Hadoop as compared with other things, right? So wherever you see huge data, wherever we see like today, everywhere huge data is getting generated. So most of the projects are getting migrated to Hadoop environment, Hadoop and Spark environment, right? Especially like ETL kinds of projects, you can see migrate towards Hadoop environment. There is a great room for this, especially Spark, Hadoop and Spark, right? For Hadoop, we have got some components like Hive, Scoop, we mostly used. Okay, fine. Yeah, any other queries? You can go with your queries, and tomorrow and day after tomorrow also you can attend the sessions to see more on this, right? Okay. Yeah.
I have a question. They say that Scala is comparatively difficult to learn and apply for someone who's not come from coding background. So what's your take on that?
No. SCALA is not a kind of, it's not like it will be very simple and easier to understand.
Okay.
So everything I'm going to discuss from the scratch ground level, right? Anyhow, I'll be spending nearly 20 days on this SCALA programming, right? 15 to 20.
So okay. From the project's perspective in the real time, right? So what are like few of the kind of projects that we have in, which can be done in Scala? One you said was migrating all the ETLs in, converting in Spark and Scala. Apart from that, what other things?
Most of the projects, everything in Hadoop and Spark environment or ETL related projects. Only.
Okay. So where we extract the data and we kind of do transformations and then load it to something, right?
At the end of this course, I'll be showing you one project flow, right? Entirely
Okay.
how this project flow goes within this Hadoop and Spark environment, right?
Okay.
Oh, yeah, fine.
So basically we'll be focusing on a project on the ETL, right?
Yes.
Okay. And this is the main application in the job, if you see in the current job market.
Yes.
Okay.
Hello, hi sir. I have one more question.
Yes, and right. And before this, right? Any prerequisites means like basics of SQL, basic SQL knowledge is required. And if you for Spark, right? We are going to discuss Scala language. Anything I will be discussing Scala for Hive HQL and for Pig Latin. So basic Linux knowledge is required, basic Linux comments. But anyhow, I'll be briefing you 1 or 2 days on this basic Linux comments. Even if it doesn't have knowledge on Linux, then like 2 days I'll be discussing about. Not that entire the basic Linux comments knowledge is enough, and basic SQL knowledge is enough, right? So we are not see Hadoop doesn't use here. We doesn't use any databases. Right? Hadoop doesn't use any database, but we are going to pull the data from database to Hadoop, right? So it requires like how we are going to do that. Yeah, some query was asked.
Yes, sir. My question is, sir, means we can understand without too much having knowledge on programming, because I am from basically non-IT sector or non-programming language. I have only knowledge only on SQL. Means because from last 2 months I am working only on SQL. So is it right course for me, sir?
Yes, sir. Those who have got SQL knowledge, even basic SQL knowledge is enough for performing this. In Scoop, some components will be in Scoop, in Hive, right? Just Hive is the main component in Hadoop, right? For data warehouse kind of environment, right? I'm saying HQL similar to SQL. So basic SQL knowledge, basic Linux, even if it doesn't have Linux, also not a problem. I'll be just improving you with the comments. Right? And much programming, not like we have got many inbuilt transformations and actions. If you see in Spark, right? Spark execution model, we have got inbuilt. We won't see huge codings here, right? Previously, huge codings, MapReduce was there. There was huge codings there. That's why it got outdated. Now we are not using much. We used to have much codings there, but later, once this Pig and Spark, right? Very less coding we are going to see. We have got inbuilt features, transformations, and actions, right?
Yeah, thank you, sir. I am done with my questions.
Hi, sir.
Yes.
Yeah, how much duration for this course?
So here it's a combination of both Hadoop and Spark, right? So previously Hadoop and Spark were separately dealt. Previously they are two different separate courses, but now combinedly we are giving it as an offer, right? It's an offered batch, but I'm going to spend nearly 45 to 45 hours on that both Hadoop and Spark environment. So nearly 80 hours, 80 to 90 hours, 2 to 2.5 months it goes. So you will be getting in-depth in brief about this Hadoop and Spark, right? You will be getting command on this Hadoop and Spark with multiple working examples we'll be discussing.
Okay. And just before you said about the ETL tool, right? Our project is mainly
No, ETL kinds of projects, right? ETL kind of things, right? Totally like those are getting migrated towards Hadoop environment, I'm saying. Previously, ETL kinds of things are getting migrated towards Hadoop environment. Wherever you see huge data involved, right? Compulsory that huge data and storage and processing, we see like this Python. What is this? Spark and Hadoop, right?
Okay.
And my major concentration will be on components on Spark, Hive, Scoop, right here. So
Okay.
Spark, I'll be just discussing mostly on Spark, Apache Hive, Scoop, Yarn, and NoSQL databases. Outdated, there are some outdated components. I'll be just giving you the knowledge on it, but mostly concentration on the components that are mostly used, right? Yes.
Okay, sir. Thank you.
Hello, Vijay.
Yes.
Yeah, actually, I'm in the background of electrical engineering.
Yes.
So now I'm decided to come back to IT sector. So is the right course to me to take this one?
So previously, one second. Previously, when if you go back like 5 to 6 years back, where MapReduce was mostly used at that time, there was less usage of Spark, right? That means it was Spark was in the introductory level. At that time, I should have said you right. People from non-programming background or those, if this component MapReduce where huge program coding is required, I should have said the answer. No, you people will feel a lot of difficulty or problem in doing this coding. But MapReduce where huge codings, now that component got outdated. All the other components, see here, Pig Latin, 100 lines of code previously of MapReduce code, I can write within 6 lines, right? The easiness of Pig. 100 lines of coding of MapReduce, I can write within 6 lines in Pig. That is what the easiness of Pig Latin. Even Spark also the same thing. Very less coding we are going to see. Inbuilt functionalities are there, right? So only one thing is every day you need to spend time with the practicals, right?
And
To complete the things you need to ask is an interactive sessions, right? You need to keep on asking the doubts and queries wherever you get, and you need to complete that day practicals that day itself, and you need to work with your own assignments. And I'll be giving some tasks for each and every component, so you need to work on those things, right? So
and one more thing.
yes,
For me, it's a very it's a long back. In around 6 to 7 years, I was studying. I mean, 2014 I was passed out. After that, I was joined in electrical sector. I was worked there, and now I come back to again IT sector. So I'm thinking about either I can do or not.
yes. One thing here, you need to go just what are the knowledge I'm going to provide you, right? What are the working examples and what are the knowledge it's not like I'm not taking just 1 month or 1.5 months in completing
Yeah.
this. So I'm spending time with you with multiple examples. So nearly a 4+ guy, how much experience is going to have, that experience I'm going to provide you with these examples, right? And you too can keep some experience and just attend the interview so that you will get more calls, right?
Okay.
So at the end of this, right, of course, I'll be just briefing you. I'll be providing you those resumes and the resume building. That things I'll be helping you out in that. Right?
Will we get any kind of documentation, some notes on whatever you're covering?
Yes, compulsory with the need comments. I'll be providing you topic wise.
Okay. Will it be like on a day basis, week basis, or end of the course?
Daily, so it will be like a daily or every alternate. I'll be providing every alternate days. For example, take the example of Hive. So Hive introduction. So what is the Hive? Everything I'll be just showing you like step by step. Practicals also, everything I'll be showing you. Fine. Array, struct, and map. What are the different data types in Hive? Simple array, struct, everything clearly. I'll be showing you working with array, working with these things, right? So I'll be forwarding you this notepad files.
Okay.
And even whatever I do practicals, right? I'll be just storing in one notepad or Word document, and I'll be forwarding you wherever you got struck up. You can just go to clear notes will be provided for this, right? Not a problem.
Okay. So apart from the notes that you provide, we don't have to go through any other, there'll be no need to go through any other documents for any other information, right? Because there's a lot of information available out there. That's why.
A lot of examples I'm going to show you, right? So it's not required. So
Okay.
I'm spending nearly 90 hours, right, on this.
Okay.
So
You will be getting the recorded session of each, right? Every session is video recorded. You will be getting that recorded video also. And just to go through, if you got any doubts or queries, if anyone from non-programming, right, even you can just go through and just do your practicals for getting command in this.
Okay.
And Vijay, how we can receive these videos for the recording? Either you can send it to us by email or you can send it in your, you can put it in your website.
In Google Drive, you will be having Google Drive, right? It will be forwarded to your Gmail.
Okay.
Google Drive, right? So you can just view in that In that,
So Vijay sir, in case if we missed this session, this session is 4 p.m. right? Every day,
yes,
45 minutes.
yes.
Saturday, Sunday also.
No, Monday to Friday. These sessions will be from Monday to Friday, right? So you can just attend the sessions. If you miss, you will be getting the recorded session of it. Still, if you want any particular component, if you have missed because of some office work, because of ill health, right, you can attend in other batches also, right? At 5 p.m. also there is one Hadoop batch. 4 p.m. there is another batch, right? So
Because since I am working like this time, I'm probably having the meetings, so that's why I'm asking. Can I get the recorded sessions of this?
yes, recorded sessions will be getting in daily basis. You can go through. If any day you can attend, and if you have got any queries, you can ask me those, right?
One more question, might be it's already asked. I want to transfer my career to big data. So after this means course completion, can I easily transfer myself as a big data engineer?
Yes. So
And
Hadoop and Spark, right? Both. That's what I was saying. 4+ years guy, how much experience? That much knowledge I'm going to provide you, right? Yes.
okay, and with this session, can we hands-on any live projects at the end, or with going session we are having something like that?
At the end, you will be having one total flow of the project, and during this sessions, right, many working examples will be discussing that. Step by step, everything will be exploring the things.
Got it. Thank you.
Hello, sir. Hello.
Yeah. Go ahead.
Yeah, right now I'm working on PLSQL domain.
Yes.
So I'm thinking to transfer big data. So is it right? Is it right? Or my decision was right or wrong?
So, yes. Big data today, if you see, big data has got a great boom, right?
Yes.
Everywhere you see huge storage and storage and processing. So, and that too, you are telling that you're from SQL or SQL background, right? So it will be
Yes.
much more simple and easier for performing.
Okay. And what's my friends are suggesting? They are keeping Hadoop and ETL tools in Naukri, but they are getting less calls. So they are telling.
That's what Hadoop previously only Hadoop was enough, but now Hadoop is not enough to get a job, right? Compulsory, you need to have the knowledge on Spark. Compulsory knowledge on Spark is compulsory.
Okay.
So only Hadoop is not sufficient. Now Spark, a very high speed processing, right? So that's what my more concentration will be on Spark, right? Spark is you need to have Spark.
Okay. And
Vijay, one more question.
Yes.
yeah. Hello.
What about Saturday and Sunday classes? It's available or not for Saturday and Sunday?
It is Monday to Friday, but if you see at the last week we are running out of days, I'll be taking.
You mean if I miss the class and from Monday to Friday, then I can attend the Saturday classes?
Monday to so you're talking about PySpark?
No, I'm talking about Hadoop, Big Data, and Spark. What about the classes on Sunday and Monday and Saturday?
Saturday, Sunday, there won't be any sessions.
There's no.
It is a regular batch from Monday to Friday.
Okay.
But if you see at the last, we'll be having some sessions if we are running out of days, right? Some bigger sessions.
Okay.
At the end means at the end of that time. Okay?
Fine.
Vijay sir, one doubt. How can I see this? This is a new playground for me. So is this big data is different from a data engineer? Means how can we differentiate this type of engineering stuff?
Pardon?
This is the new thing.
You are from which? You are from which background?
Yeah, I am from C++ and Linux background, and I want to transform myself to as a big data. So how can see like big data and data engineering? It's both are the things are same or the same stuff both are doing?
So I can say big data as a problem, right? If I take one second, if I take big data as a problem, I can take Hadoop as the solution for it. If I take big data as a concept, I can say Hadoop is the implementation for it. So huge data generation, right? If I take big data as a problem, Hadoop as a solution for it. So huge data generation, right? So I can store it, I can process it within quick time using this Hadoop and Spark environment. Right? If I take big data as a concept, I can say Hadoop as the implementation for it.
And what is the role of data engineer then? Like it is also included in this, like pipeline and all?
Yes, everything that's are included in it. You are going to pull the data from different sources, right? And you are just going to store it in a Hadoop HDFS. They're using any of the processing components like Pig or Spark or like you are just going to process it. After process results, again you can export it back to that any of the databases or NoSQL databases. That's the
So,
total. Yes.
so can we attend the recorded sessions on weekends, on Saturday or Sunday?
Can we? I didn't get you. Saturday, Sunday.
Can we attend the recorded sessions on Saturday and Sunday? Because I'll be having time on Saturday and Sunday only.
You can go through that. If you have got any queries, you can just ping me, right? A separate group will be there for directly. You can have a direct discussion directly. You can interact with me through group, right? We have a WhatsApp group where you can just ping me. I will be giving time. You can just you can clarify your queries during that time.
Okay, then it means the recorded sessions will have that much of validity.
Validity, you will be having 6 months, right? 6 months validity.
Okay, okay, that's all. Thank you.
Thanks.
Sir, is Spark with Scala enough, or do we need to learn PySpark also?
Spark knowledge is enough. Spark is the execution model. You can implement in different languages, Scala and Python. So you are only the programming is going to change, that whether you are implementing using Python or using Scala or using Java. Java is very less used, but Scala and Python, Scala is the native language of Spark, but even Python also mostly preferred, right? But any of it, you need to have the knowledge on Spark.
Okay, so which could be the better one, sir? Either with Scala or with Python?
Previously, like 50-50, right? The usage of Scala. In India, we go for Scala, but if you see in the US, PySpark usage is not. Usage of Python is not.
Okay. And one more thing, sir. So from when the 5 p.m. Classes will be getting started?
5 p.m. you are talking?
Yeah, as you told, right? So there is another class which will be starting from 5 p.m.
Yeah, already batch going on, right? 5 p.m.
Okay, so as of now, I can't able to join that, right?
No. After your basics are completed, later you see components. Nearly we have got 10 components, right? Some components you want to can attend at 5 p.m.
Okay, that's it, sir. Thank you.
Fine. So I'm running out of time, right? So if you have got any queries, you can attend the session tomorrow, and you can ask your queries in the tomorrow session also. If I'm done with the queries, I'll stop here for today. Meet you tomorrow, same time. You can use the same link for tomorrow's session to see more on this Hadoop, right? Yes. Thank you all for your time. Thank you.
Thank you.
Thank you.